Okay, folks, another example. So let's look at how do we implement F using NAND only. So there are multiple ways to do this, but we going to use K-map. So if this, let's say we do it this way, using this, you could do it this way too. Hope you know the difference. The difference is the location of minterm. So the location of minterm for this, the location for minterm for this will be 0, 0, 1, 2, 3, 4, 5, 6, 7. For this is 0, 1, 2, 3, 4, 5, 6, 7. So when you have that, let's fill in the its location 3, 4, 6, 7 with a D here. 3, 4, 6, 7 with a D. So now what we're trying to do, 3, 4, 6, 7 and D. 3, 4, 6, 7 and D at location 0. Okay, so the bigger box that you can draw, that's one. This is the next one. Okay, so the variable that doesn't change here is x2, x3. The variable doesn't change within the box. If you look at the box, it covers up 3 and 7. If you go between the column, x1 change from 0 to 1 or 1 to 0, but if you look at the row, x2 and x3 doesn't change, it stays constant. For this one, it is in the x1 column, but we only want our box only cover minterms 4 and 6. If you just pick x1, that include the whole column, that include 5 and 7. That's not what we want, so we need to pick another variable. If you look at this, is right there. Do you see that? It doesn't change. So it's x3, the 0 version is not. So f is x2, x3, x1, x3 not. So now let's go ahead and draw this. So 2 big AND gate, right, to cover the 2 minterm, and x2, x3, okay, x3 not, and x1 and f. So if we want to implement this using NAND gate only, is we're going to add bubble. And remember that the De Morgan's theorem, one of them is this. This means that if you have an AND gate, NAND gate is equivalent to this. Okay, so add a pair of bubble at a time. Okay, now we know that this is a NAND, this is a NAND 2, and this is a NAND. The only thing left to do is this inverter. This inverter is actually equivalent to this, and I believe you should be able to prove this where a 2 input a NAND gate, when you tie both input together, is actually equivalent to an inverter, and you should be able to do this and prove that using a simple truth table. So now let's redraw this. That's what we have. Okay, and that's x2, x3, and x1. Okay, that's another example done.